Kinetics is the study of the rates of chemical reactions. For any reacting system, thermodynamics can be used to predict whether the reaction will spontaneously occur. The kinetics of the reaction indicate how fast the reaction actually goes. Most of the biological reactions that occur in the cells of living organisms are greatly sped up by protein catalysts called enzymes. Recall that catalysts dramatically increase the rate of a reaction without affecting the equilibrium. The objectives for this exercise on enzyme kinetics are to comprehend how enzyme kinetics relates to the chemical kinetics presented in general chemistry courses, to understand how kinetic parameters are experimentally determined, and to learn about the Michaelis-Menten equation and the meaning of Km and Vmax. Our first objective for this exercise is to show how enzyme kinetics relates to the elementary kinetics you studied in general chemistry. Let's begin with a simple reaction, a unimolecular reaction that can be described as A being converted into B. Since there is only one reactant, this is a first-order reaction whose rate or velocity can be described as the disappearance of the reactant over time or the appearance of the product over time. The reaction rate is represented by the slopes of these lines and is not constant. In order reaction, the rate is directly proportional to the concentration of reactant. Here K is the first-order rate constant for the reaction. Although the rate constant does not change, the velocity of the reaction begins to decrease as the concentration of the reactant diminishes and the product accumulates. The rate of the reaction eventually slows to zero as the product of the initial forward reaction becomes a reactant for the reverse reaction. Equilibrium is the point where the forward and reverse reaction rates are equal, and the overall rate of the reaction is zero. In a simple enzyme-catalyzed reaction, the reactants are labeled S for substrates and products are labeled P. This looks like our first example, a simple first-order reaction in which substrate is converted to product. Similarly, the rate of an enzyme-catalyzed reaction is either the disappearance of the substrate or the formation of the product over time. As the reaction proceeds, the reverse reaction begins to compete with the forward reaction until the rates are equal and equilibrium has been reached. The rate equation for an enzyme-catalyzed reaction with a single substrate is the same as the rate equation for the simple non-enzymatic reaction, but only when the concentration of substrate is so low that the enzyme has very little chance to convert it to product. Under these unique conditions, it appears that the reaction is first order with respect to substrate. However, this special case is much too limiting and rarely applies in biological and experimental systems. Consequently, biochemists must use a different model to describe the kinetics of biological reactions catalyzed by enzymes.